Hello class. In this video we're going to talk about exponential derivatives, and these are going to be some of your favorite derivatives. The derivative, we're going to start with the e exponential function because its derivatives is just itself. And so that one's going to be one of your favorites. Now, what happens if we expand to other bases? Well, it's not much of a difference. Use a as our base, and it becomes a to the x times an additional constant natural log of a. Now, if we really quickly applied this rule to e to the x, we'd get e to the x times natural log of e, but the natural log of e is just 1. So those are the two rules we're going to work with. Now, we will need our chain rule because, of course, nothing's ever that simple. All right, so let's start with y equals e to the power x plus x squared. Okay, so we're going to set up dy dx. And we're going to use it, again, we're going to want to be equipped with chain rule. I'm still going to call it the inside, even though we're using the exponent, just so we can keep that relation in the back of our mind. Okay, and then we have to calculate d inside. Derivative on the inside is 1 plus 2x. So when we calculate our derivative, we're going to take the original function as is and copy it. And then chain rule means we multiply the derivative of that exponent. Now, because we have base e as our exponent, we're not going to add anything else to our function. We're done. If we had a base like 2, then it'd be times natural log of 2. So let's go ahead and look at another example. This one actually does have base 2. So let's talk about the exponent is just t this time. And remember, the derivative of constants is still 0. So when we do f prime of t, again, just copy the original exponential function. And since we're not base e, we got to multiply by that constant, the natural log of 2. All right, now let's try another one. Base 3 here, but we have an inside, quote unquote. So we're going to start with the inside is cosecant x. So we'll have to recall what's the derivative of cosecant x. Derivative is negative cosecant x times cotangent x. So when we find our derivative, dy dx, we copy down our original function. We multiply by the derivative. I'll bring that negative out in front. Times cosecant x times cotangent x. And then we're going to multiply again, since it's base 3, by the natural log of 3. All right, let's calculate the fifth derivative of y equals 7 base log 7 of x. So here we would do, again, our chain rule. Log base 7 of x, and then d inside. Well, we need the derivative of logarithm, and we've actually never talked about that. So what is this, a trap? Especially because fifth derivative, are we going to derive it? No, this is actually, we don't need the chain rule. I tricked you. 7 to the power log base 7, those would cancel out, and you're just left with y equals x. And so when you calculate your first derivative, that's just going to be 1. And then your second derivative is going to be 0. And then every subsequent derivative will also be 0. So the fifth derivative is also equal to 0. Go ahead and give the exit ticket a chance. Thank you for watching.